Hi, this is Miss Logan. Today I'll be talking about vectors in physics, which is chapter 3 in the AP Physics book. So just a little bit of a review. So what's the difference between a scalar and vectors? So scalars are numbers just with units. We do not have a direction. However, vectors have a magnitude, which is a number with units, and a direction. Okay, so for instance, this example down here, if I'm standing in the middle of this circle, I know I have 0.5 miles to get to the library. However, I don't have a direction, so I really don't know where exactly I'm going. So just the 0.5 miles, this would be a scalar. But if I had 0.5 miles south, that would give me a vector. Okay, so we're going to be using vectors a lot when we get into anything that's two-dimensional, okay? So we know how far away something is, but we may not always be able to draw a straight line. And by a straight line, I mean it's only going in the x or it's only going in the y, okay? So one of the most important things about vectors is that all vectors can be broken up into an x direction and a y direction, and we'll talk about how to do that in a minute. Okay, so the vocabulary we often use is called resolving a vector, okay? And that is putting our vector into a two-dimensional coordinate system. So this example over here, I have a vector that is 1.5 meters long, and it's going at an angle of 25 degrees to the x-axis, okay? Now if we look at this, I can break this down into my x component and my y component, okay? So how do I get these numbers? I'm going to use trig, okay? That's why we practice it so much at the beginning of the year. Okay, so if I have a vector, and in this case, my vector is called A, this symbol right here, this arrow, is going to tell me that it is a vector, okay? Now, before I break it up, it's always important that I make my coordinate system. This is something we're going to be really doing more, drawing pictures and also creating our own coordinate systems, okay? So to show that this is going in the x direction, I have ax, and to show in the y, I have ay. This could be different if I had a vector called r. This would be rx, and this would be ry. All right, so we can actually add vectors graphically and figure out what our resultant is, okay? How do I do this? The only way I can is if I place the tails, and the tails need to match up with heads. So this is okay right here. I cannot do something like this. I cannot add vectors like that, okay? It doesn't make any sense. So if I'm looking at something graphically, I need to always break up things into the x and y components, and we're going to do this without numbers at first, just so we can really think about it. So our first one says I'm going 5 paces to the north. So that is in the y direction. So I have a right there. If I had numbers, I could put numbers attached to this. Next one is 3 paces east. So that's in my x direction. So I can put my vector b here. Okay. And then my last vector is 4 paces southeast. Okay. So I have a y and an x component. My x component is going in the positive direction, so I can have cx. And then I have cy. But is it positive or negative? It's negative. This is why it's really important with vectors that we actually draw them out so we can look at the direction that they are going. So this purple line right here is representing our resultant. And we'll do this in an example problem in a second, but what I'm doing is I'm finding what my x added together and what my y added together, and that should give me my resultant. Okay, so just like I showed, adding vectors using components, this is going to basically what we're going to be using for the remainder of this unit and on the next unit. So I first need to find the components of each vector, so that is breaking up into x and y. Okay, then I need to actually add the x and y components separately. I always like to use t-charts. Then we'll find the resultant vector. So let's actually dive in and just do a sample problem together to see what this looks like. All right, so this vector right here, and they kind of broke it up for us, which was nice. They had two vectors, A and B, together, okay? And A and B have a resultant, which is the purple line right here. And they also broke up our components into X and Y components as well, okay? So I'm going to actually give some numbers to this for us to actually apply it. So let's say that A is 30 meters, and it's at an angle of 60 degrees, and B is at an angle of 30 degrees and is 20 meters long. Okay, and we're looking for the resultant. Okay, so I actually have two triangles, and I think it's sometimes nicer to actually write them out separately from each other just so we can focus on them. Okay, and I'm going to make my X and Y T-chart. Okay, so let me make this T-chart. So I have X and my Y components, okay? So I have 60 degrees, and I have 30 meters, and then I have 30 degrees and 20 meters, okay? So we need to find both of our X's and both of our Y's, okay? So how am I going to figure out this X component? Well, I need to use trig. So for this instant, I'm going to use my cosine because this is adjacent. So cosine of 60 degrees equals X over 30. I'm going to do some math, and I should get 15. Okay, so after I get these, I like to put them right into my T-chart just so I know what is going on. All right, so let's do our Y for this. So this one is going to be the sine of 60 equals Y over 30. For this one, I'm going to get 25.98. So I encourage you during this to pause and actually do the math. I'm just going through it a little bit faster. All right, for my other one, it's also going to be cosine. So it's going to be cosine of 30 degrees equals X over 20. It's going to give me 17.32. My Y is going to be sine of 30 degrees equals Y over 20. And that'll give me 10, okay? So from here, I need to add these together. So I like to emphasize the add because if I had one of these going the negative direction, it would actually be subtraction, okay? So these are going to be my final numbers for my vectors, okay? Now, I'm not done yet. I have to make a new triangle. So I'm going 32.32, and then I'm going up 35.98, okay? So we're looking for this resultant and this angle, okay? How am I going to figure this out? Well, I'm going to keep using some trig. So if I use a squared plus b squared equals c squared, and I use these two numbers, I'll be able to figure out r, okay? So if I do that math, I'm going to get 48.36, okay? And to figure out the angle, I'd probably use tan. I recommend using tan just in case we messed up this number right here. Okay, so the angle I'm going to get is about 48 degrees. So this is a typical problem when I'm breaking down I'm adding two vectors together and I'm breaking them down to X and Y. This final step, though, is the most important, figuring out the resultant and the angle it is at.